Derek Briggs here, Product Manager for Tsugami America. I'm here to talk today about a non-round function on your Tsugami machine. Let's get started. So before we get started on the machine and control itself, there's a critical component to this, the three critical components to the non-round function, and that is making sure that you have pins and keys in your collet and guide bushing system. So what I have here is guide bushing, which typically always come with a keyway in them. So some machines have 3mm, some machines have 4mm keyways. It all depends on what size machine you have. Typically it's a 3mm keyway in a guide bushing. Then you also have, because we have a hex collet or a shaped collet, we need to be able to orient that collet. Now it's a little less typical to see a keyway slot in a collet. So that's kind of special to the shaped collets. So when you order these, you want to ask the collet manufacturer to put a keyway in your collet. Now, in your instruction manual in Chapter 9, it will tell you if you have a non-round collet sleeve, like this one that has a pinhole in it, this is for a 3mm pin, and it will tell you the diameter of that pin. Our bigger machines, as far as Tsugami is concerned, that takes a 4mm pin on the main spindle. Our smaller machines take a 3mm. So today we're working on an S206 Mark II. So this has a 3mm pin. You can get these pins anywhere from MSC or like Master. They're just a hardened pin. We get them in 10mm length, and you tap that pin in. So as you can see here, the pin does not protrude past the inside diameter of the spring. The reason for that is this keyway slot in the collet is actually not, it doesn't actually break through this back face here. So if your pin was too deep, you would actually hit this back face and you wouldn't be able to push your collet all the way back. So it's critical to push the pin through enough to hold the spring back. So you always want to put your spring in first, then put your pin in. And you want the pin to hold the spring back, but just enough to hold the spring back. You don't want to push that pin in too far past the inside diameter of the spring. So critical parts, we have to have keyways here in your collet and your guide bushing. You have your pin in your sleeve with your spring behind it. Time to put the sleeve in the machine and start getting the parameters set. So one quick tip I wanted to bring up is if you're doing a lot of jobs that you're switching over from non-round bar to round bar back and forth a lot, let's say you're doing this 2 or 3 times a week or even 2 or 3 times a month, I would advise to get a second collet sleeve. That way you can have one with a pin in it and one without. That way you're not putting a pin in, taking it back out, and switching over all the time. So a secondary sleeve in your inventory is a great way to make faster setups if you're switching over between this mode and standard round bar. The other method, and this is really only going to be applicable if you don't already have a large inventory of collets. If this is your first Swiss machine and you only have a few collets in your inventory, maybe just start ordering every collet you have or every collet you need with this keyway slot in it. That way, every collet, doesn't matter if it's round or shaped, you can just leave the pin in your collet sleeve and it will always fit. So there's 2 methods to do that. I highly recommend just getting a secondary sleeve if you're going to be switching over to non-round often. So now that we've got our sleeve inserted in the machine and our collet nut on and our collet tension set, now we can start going through the control itself to set the parameters and actually get our guide bushing and our main spindle aligned with the separate C-axes, okay? So the first thing you want to do is make sure that this option is actually turned on in your control. If your machine is newer than about 6 years, Tsugami America turns all these parameters on. If you go to offset 2 times, and that'll bring you to the settings screen, you're going to soft key right 1 time, operator panel, and page down 2 times. And you'll see shift set and non-round. If you try that on your machine and this does not show up and it's blank like these up here, Chapter 9 of your instruction manual will have non-round function parameter settings. If you would like to just contact Tsugami America, we can walk you through it as well if you cannot find it in your manual. So again, 6 years or newer, all of this should already be turned on. All those parameter settings in Chapter 9 should already be set. The only thing that's not set from the factory is going to be a couple of keep relays, and that's because you only want to set these keep relays when you're running non-round bar. If you're not running non-round bar, you want your guide bushing motor to be fully energized, synchronized with that main spindle rotation, because otherwise it could slip on your bar stock. When you're running non-round material, or say shaped material of any kind, you actually want to relax your motor, because if there's any error or twist in your extruded material, like extruded hex or D-shaped material or square or whatever shape it may be, if it twists it all down the bar, it could put a little bit of the guide bushing motor will fight the main spindle motor, and you really don't want that to happen. So what we do is we kind of turn these keep relays on to relax that guide bushing motor and allow it to kind of have a little bit of play. And that's what makes this work so well. So what I'm going to do here, non-run was on, everything is off. First thing I'm going to do is I'm going to turn on parameter right enable. It's the first step. So if I go to the settings screen, I'm going to press 1 input. I'm going to get this alarm. Because we have to do quite a few things while the parameter right enable is turned on that you really can't do if this alarm is on, what I'm going to do is press reset and cancel. If I push those simultaneously, it's going to make this alarm go away, but also keep parameter right enable turned on. So that allows me to move the machine around and do some functions in MDI that normally wouldn't allow you to do with this alarm. So press reset cancel. Now the alarm goes away, but my parameter right is still turned on, so I can still continue on with the process. If I press the system hard key, it's going to bring me to the parameter screen. Soft key arrow right 2 times, PMC maintenance. I'm going to soft key right 1 time and keep relay. So the keep relays I want to change is 19-bit 1 and 19-bit 2. So this is a hexadecimal system, so 0 starts from the right side. So 19-bit 1 is going to be the second one in. I'm going to change that to a 1 input. And then 19-bit 2 also 1 input. 19-bit 3 is called out in the manual that it needs to be a 0. This is typically already set to a 0 at all times, but just if yours is set to a 1, change it to a 0 for this process. So the keep relays are all set. While we're in this screen, the other thing I'm going to do, which I'll get to later, but since we're already here, I'm going to set it, is my torque skip value. I will explain that in more detail when we get to the actual bar change program portion of this. But since we're here, I'm going to press data, and I'm going to go down to D0900. I'm going to press OPRT and zoom. Okay. Now to set my value for my torque skip, it's my Z1 axis torque skip. I'm going to type in 9904, and I'm going to select search here. That's going to bring me to data table number 9904. I'm going to set that to 50. And again, I'll go over that value, what that all means later on in this instruction. But for now, we just set it to a 50 and we are all set. So the next step is going to be, I have now my, with non-round turned on, if I press offset, go back to my operator panel and I turn on non-round. The goal is, non-round allows me to have a second C-axis. Now, instead of my guide bushing being synchronized with my main spindle at all times and just mirroring whatever my main spindle does with C-axis, I've given my guide bushing its own individual C-axis in addition to the main spindle C-axis. So, what I do is I'm going to go to MDI, M50, end of block, G28, H0. That's going to home out my C-axis. It's going to rotate both main spindle and guide bushing, and it's going to home those out just like it normally would any other time. But what I'm going to do after that, this is what makes it unique, is M150 on the main side. Typically M150 on the sub side is going to be your C-axis. M150 on the main side is going to be CG axis, which is my guide bushing motor C-axis. So I'm going to do CG, I'm going to go end of block G28, HG0, like that. So basically the same thing, except HG, okay? That's my guide bushing. So as you can see, you watch the main spindle and guide bushing rotate. Clamp my main spindle collet. And now the C-axis on the guide bushing rotates independently from the main spindle. So now I've set my CG to 0. Now that doesn't necessarily mean that the shapes of the main spindle collet and the guide bushing are actually aligned. It means that both the main spindle and guide bushing are at C0, their respective C0s. But that doesn't mean that the shape of the collet and guide bushing are actually lined up. That's what we need to adjust. And in order to do so, we're going to adjust the CG0 position. So we go back and we're going to turn on shift set. So this is only turned on during this setting function initially. Once this is set, you just run the machine in non-round mode. Once we turn this on, you'll see the cycle start light starts flashing. This will disable the ability to hit cycle start. So we can't do anything in MDI. Nobody can accidentally come up and actually hit cycle start. We can still navigate the control, but it kind of eliminates us from doing certain things and also reminds you that shift set is actually still on. So once that's on, what that allows me to do is C-axis on my main spindle is tight, but I can actually rotate my guide bushing completely independently now. So now I can actually rotate that around. I can see what my degree of orientation is by pressing System 2 times from that last screen, Diagnosis, 301, Number Search, and you'll see this CG right here on Diagnostic 301. As I rotate this guide bushing, it's telling me what is the clock position of that guide bushing on the fly. So what we're gonna do is we're gonna unclamp our main spindle. Okay, so now my bar is free inside of here. I am gonna feed this bar through. Remember, my main spindle C-axis is actually locked, so that's not gonna spin. I need to rotate my guide bushing until my bar slides through, just like that. So I got my bar to slide through, and you can feel it. Now I'm locked in. One note is make sure your guide bushing is a little loose for this procedure. It's a lot easier to put that extruded hex or shaped material through the guide bushing. Sometimes those materials vary in size a little bit, so if you have your guide bushing set as though you're running production, it may be a little too snug to push through by hand. So just leave it a little loose until this process is done, and then you can tighten your guide bushing up once you have your new C0 set for your guide bushing. So I have it set. The next step is I'm gonna open and close my collet again on the main spindle, and that's gonna orient that main spindle. It's gonna make sure that it kind of pulls it into place. So I clamp, unclamp, and then I'll clamp again, and that kind of shifts it into place, and now I'm holding it tight. So you'll see CG is 80.771 degrees. In order to set that as my new CG0, I'm gonna take that number and I'm gonna multiply times 1,000, which will give me 80,771. So now that I have that number, I'm gonna subtract 360,000. That's gonna give me a negative value of 279,229. That number is what we're gonna place into parameter. If I press System again, and one more time, it'll bring me to parameters, 4135 on the main side, number search. S3 is gonna be my CG axis, my guide bushing spindle. So all these are spindles. S1 is your main spindle. S4 is your main, your front cross spindles. S5 is your rear cross spindles, and S3 is your guide bushing spindle. So what we're doing is we're gonna set that negative go to MDI first, negative 279,229. And I'm gonna press input. Now, because I left parameter right enable on earlier and just press reset cancel, I didn't have to turn it back on again now. So I set that value, okay? Now I can go back to offset and turn off shift set. That turns off the cycle start light and allows me to enter values in MDI again. So I'm gonna execute M51 and M151 to cancel my C-axes on both the main spindle and the guide bushing. And the next step is just emergency stop and power the control down. Turn the control back on. And once we turn that on, we're gonna double check what we just set. Okay, so now the control is booted back up. I'm gonna release my emergency stop. If you have a chip conveyor, you may get a chip conveyor alarm. We'll reset that. So now what we're gonna do is just test to make sure that CG0 that we just set actually does line up our hex now between our main spindle, and we're gonna feed it through manually, nice and slow, to make sure that everything feeds through like it's supposed to. So first step, we left our main spindle clamped and our material through the guide bushing, so I'm gonna jog unclamp my main collet. I'm gonna pull this material back through. So now I'm back through, and I'm gonna reclamp that main chuck. And we're gonna go through that same process in MDI, turning on C-axis. So MDI program, M50, and the block insert, G28, H0, and the block insert, M150, and the block, G28, HG0, and the block insert. And I have this all the way down to 0. If I press cycle start and turn it up to 10, you'll see C-axis and then CG-axis. Completely independent. So at this point, we have our main spindle collet clamped. I'm gonna unclamp and pull a little material out manually. Make this a little bit easier. I can actually pull this out manually and slide it right through. I already know this is gonna be lined up just because I slid it right through by hand. So just to be safe though, what we're gonna do is we're gonna leave it right there. I'm gonna reclamp and I'm gonna slowly handle. Now, if you wanna watch this, you can either watch it on the mechanical side, just watch the back of the guide bushing motor itself to see if it twists at all. You may get a slight twist, but as long as it's not too much, it's not gonna alarm the machine out or cause any damage. Again, this extruded materials, these shaped materials, sometimes as they get extruded, they wanna twist as they come down and come through the bar, through the extruder. So there can be a little bit of a twist because the distance between your main spindle collet and your guide bushing is so great. Regardless, what we're gonna do is I'm gonna press the position screen. I'm gonna soft key right one time and I'm gonna press monitor. And I'm gonna watch this Z-axis. As I handle Z1 forward, nice and easy, I'm gonna feed that through until I come out the front of the spindle. Now if you feel, you'll be able to feel resistance, or you'll see a movement of the guide bushing if it's not lined up. So as you can see, I am through the face of the guide bushing, everything lined up exactly like it's supposed to. I didn't get any load, any excessive load on my guide bushing at all. It's perfect. So I know that what our procedure just worked, no problem. And we're ready to move on to our actual automated bar change program, which is gonna be different than your standard round bar program. So we'll get into that next. Now we want to create a bar change program, an automated bar change program, separate from your standard 9002 program that you would normally use for your round materials. I don't like to edit that program. Keep that one just for round materials because you're not going to run the machine in non-round mode when you're not running non-round material or a shaped material. So if you go back to round bar, go ahead and turn that off and run it without, and change your keep relays 19-bit 1 and 19-bit 2 back to 0 to run in your non-round. Okay, everything else can stay the same. So what I do is I create, instead of a 9002, I'll create a 9003 program. 9003, and then in any program that I write that has shaped material, instead of at the end of the program, you have M95, block delete, M92, M96. That's the order to call up your bar change program. What I would do is M95, block delete, M93, M96. And that's always gonna stay resident, so you don't have to think about it anymore. Leave your 9003 program in, you run that part again a year from now, it's gonna automatically call up the right bar change program. As long as you have non-round turned on, you're all set. You'll know right away if you don't have non-round turned on and you try to run that program, because M150 on the main side will not finish. That it'll just hang up on M150 if you try to execute it without non-round turned on. So that's gonna be your dead giveaway. All right, so I've already created a 9003 program. This program is actually in the Tsugami manual in chapter 9, along with all the other non-round specifications. But I kind of make a few tweaks to this to make it a little bit more advanced and let the operator know if something went wrong. So the most important thing, which I brought up earlier, is torque skip on Z1 axis. So what happens if our guide bushing slips or our pin breaks maybe, which very rarely happens, but there's a possibility that somehow something could get tweaked in the main spindle, or maybe you changed your main spindle collet to a different one. That keyway slot might not be in the same spot, and if you don't calibrate like we just did in this procedure to the new collet, it may be off by 1 or 2 degrees, and you might get some binding when you try to feed that new bar through. And that could alarm the machine out or cause damage. So what we do is we use Z1 axis torque skip as we feed through. So what we're doing is we're reducing the amount of torque that it takes to alarm the machine out. So in that data table that I set earlier, D9904, I set it to a 50. 255 is full torque, 100% torque. What I did was I set it to 1/5 of the full torque of the Z1 axis. So it's a much softer landing. If something goes bad, it doesn't take nearly as much force to alarm the machine out. But what we're gonna do in here is we're gonna create our own alarm. So in this program, which is gonna be exactly like the 9002 program, except a few additions to it. So you got T0, G28, U0, G97. You start your spindle up at a low RPM to help get that material out. We turn off our bar feed torque. We turn off our coolant, our flood coolant, and we back up our Z1 axis out of the guide bushing. And I just realized that this machine is in metric, not inch, so this value is actually incorrect. So we will change that to 50 millimeters. You want to draw out at least 50 millimeters or 2 inches to get out of the guide bushing. And our feed rate, we can do 2540. We'll change our feed rate there to reflect the metric machine. So if your machine is inch, you can set it up to whatever speeds and feeds you like. We're gonna stop our spindle after we load the bar. Let me back up just a little bit. We're gonna do our bar change. We're gonna clamp our collet because the bar is gonna feed just shy of the back of the guide bushing. Okay, and then we're gonna clamp our collet. So we're still not in both the main spindle and guide bushing yet. Stop our spindle, turn on our C-axis, G28H0, that's our main spindle C, and then we're gonna turn on our guide bushing C-axis, and we're gonna orient that one. Then we're gonna turn on our bar feed torque. We're gonna turn on M148, that's Z1 axis torque skip, okay? G31P98 is telling the machine to feed at the, look at the torque that's in data table D9904 and feed in millimeters per minute, which I have to change this one too. We'll go W. We're gonna feed back that 50 millimeters that we drew out. And we're gonna feed this one at 1270, okay? Millimeters per minute. So we're gonna feed back forward that same amount, just like you would in your normal bar change program, except we're oriented here. Spindles are stopped. And then once we feed there, we're gonna turn off torque skip. This is the way that Tsugami writes the program in the manual. We're gonna add something to this that's very critical in my opinion. So M51, M151, it turns off your C-axis, and then you do your normal bar change. Once you do that, everything is the same as your 9002 program. So this is really the meat and potatoes of what makes it special for the non-round. And that's what we're gonna edit here. So at the very beginning, in order to do all this, we need to know where is our Z1 axis when it retracts out, because we need to know where to feed back to. And I'll explain a little bit further. So our goal is to make sure with torque skip that our Z1 axis made it all the way back to where we started from when we ended the last bar. Because you're stopping at a certain point, you're feeding back 50 millimeters or 2 inches, you're changing a bar, and then you're gonna clamp and feed forward exactly back that 50 millimeters or 2 inches. We wanna know what is that value before I backed up. So what we're gonna do at the very top is we're gonna say, after our T0, pound 100, and you can use whatever variable you want if you're already using these variables, equals pound 5042. I'll get it there. Okay, pound 100 equals pound 5042. Pound 5042 is Z1 axis current absolute position. So we're gonna say, where is Z1 right now? And we're gonna take that value and we're gonna load it into pound 100. And then we're gonna back up our 50 millimeters or our 2 inches. We're gonna do our bar change. And what we're gonna do here with torque skip is we're gonna feed back that same amount. But what we need to do is, because when torque skip sees the torque that you have it set to, it just stops and moves on in that same, it stops the axis from moving any further and moves on in the program. We don't want to move on in the program, because what if there was too much torque and we didn't actually feed to our point where we need to cut off. Well, they're not going to cut anything off, and we're going to be short, and our first part's going to come up short, or bar feed torque could push that bar out on the next part and break your cutoff tool, and so on and so forth. So what we need to do is alarm the machine if we did not make it back to that same position where we started. So what we're going to say is, we're going to say if pound 5042 current Z position, NE, which is not equal, pound 100, then pound 3000 equals 1. Pound 3000 equals 1 creates an MC alarm. It's a user alarm. It'll be 3001 alarm. You could say pound 3000 equals 9, and it would be a 3009 alarm. I just make it a 1. It's the easiest thing. And then anything after pound 3000 equals 1 in parentheses will be the name of the alarm. So we say, you can say bar misload. Bar misload. And we're going to do end of block insert. Okay? And what I'm going to do is I'm actually going to do M149 first. So now we see we turn on our C axis, we turn on our CG axis, we turn on torque skip, we feed through where we should end exactly where we began. And then we check to make sure we did. If there's too much torque, it's going to stop before it made it there. So it's going to say, if my Z1 does not equal where I was before, then alarm out with a 3001 MC alarm that says bar misload. And that alarm will pop up and it will stop the machine in its tracks. Your operator will know the red light will be on and the machine won't go any further and it won't cause any damage. If everything is fine, if it made it to the last position, it's just going to continue on in the program and you'll never know. So that is the critical part of this that we had to add. The beginning is store my current Z1 position before I change a bar, and then check to make sure I got back to that same Z1 position as I loaded my my shaped material through. Once this bar change program is created, you are all set. You are ready to use non-round bar. One other thing I wanted to point out, and this should be set in your machine already, is the parameter for M93 to call this program. So let's go to System again. We'll get to the parameter screen. 6071, number search. So that's M91, M92, and we want this to say 93 for M93. And this parameter is associated with program number 9003. So it's already set in this machine. If your machine, parameter 6073, does not have a value here or a different value, it will need to be changed to 93 in order for M93 to call your 9003 bar change program. Thank you for watching today. If you have any other questions about your Tsugami machine, please contact us at tsugamiamerica.com.